These 3 videos will show you Skill 29, Skill 30, and Skill 31.
We want to find the measure of each missing interior angle of the given triangles. Notice our first triangle is a scaling triangle because all sides are different lengths and therefore all the angles have a different measure. Our second triangle is a right triangle because one of the interior angles measures 90 degrees. And then finally the third triangle is an isosceles triangle because two sides have the same length and therefore the base angles, or the angles opposite the sides of equal length, have the same measure. Notice out here they're both labeled c degrees. Regardless of the triangle though, the sum of the interior angles must always be equal to 180 degrees. And we can use this fact to set up equations and solve for the unknown angles in each triangle. So looking at our first example, x plus 43 plus 64 must equal 180. Notice how we're leaving the degrees off in our equation because we already have a degree symbol on the variable x. So now we'll solve this for x. 43 plus 64 equals 107. So we have x plus 107 equals 180. And now we'll subtract 107 from both sides to solve for x. So we have x equals 73, which means the missing angle measures 73 degrees. Now for our second example, because we have a right triangle, we can set this up a couple ways. The sum of the interior angles must be 180 degrees, but also the two acute angles of a right triangle are complementary or have a sum of 90 degrees. So let's go ahead and set this up two ways. Let's first use the fact that y plus 53 plus 90 must equal 180. So we have y plus, this would be 143 equals 180. Subtract 143 on both sides. And we have y equals 180 minus 143 is 37. Therefore, the measure of the missing angle is 37 degrees. The other option would be to recognize that y plus 53 must equal 90 degrees because these two angles are complementary. Subtracting 53 on both sides, we get the same result, y equals 37. And then finally, for our isosceles triangle, our equation would be z plus 36 equals 180. Z plus z would be 2z. So here we have a two-step equation to solve. We'd first subtract 36 on both sides. This would give us 2z equals 144. And now to solve for z, we divide both sides by 2. So we have z equals 144 divided by 2 equals 72. And therefore the two missing angles, which are equal in measure, both measure 72 degrees. I hope you found this helpful.
Okay, the next video is for Skill 30.
The following is a selected video from yourteacher.com, where you can browse over 450 complete math lessons with example videos, interactive practice problems, self-tests, and more. Try a complete lesson today at yourteacher.com.
To find the value of x in this problem, we use the exterior angle theorem, which states that the measure of the exterior angle of a triangle equals the sum of the measures of the remote interior angles. So in the diagram shown, the exterior angle, 3x plus 6, equals the sum of the remote interior angles, x plus 30. And solving the equation from here, we subtract x from both sides to get 2x plus 6 equals 30. And subtracting 6 from both sides gives us 2x equals 24. And dividing both sides by 2, we find that x equals 12.
Okay, and our last video in this segment is for skill 31.
Parallel lines and transversals, a la schmuck. The U.S. women's gymnastics team knows all about parallel lines. The parallel bars consist of two bars that maintain the same distance from each other and never touch. Sort of like Tom Cruise and Katie Holmes' pre-separation. Parallel lines follow the same principle, except that it's more difficult to perform gymnastic routines on lines. A transversal is a line that runs through or connects two parallel lines. When a transversal intersects with parallel lines at right angles, it is called a perpendicular transversal, PT to everybody. With any other sort of transversal, the pairs of angles across from each other, known as consecutive interior angles, will be equal to 180 degrees. Sometimes you might not be totally sure whether lines are parallel or not. Don't let it keep you up at night. We're happy to tell you there's a trick you can use. Look at the corresponding angles. If the corresponding angles are equal, it means the lines are parallel. But if the corresponding angles are different, even by 1 degree, the lines are not parallel. One way that parallel lines and transversals are used in everyday life is in urban planning, which includes the construction of roads, highways, and buildings. Deciding the exact route for city streets, including where they will cross each other, requires an understanding of parallel lines and transversals. We're certainly impressed by parallel lines and transversals, no matter what Michaela thinks.
Okay, your assignment for this section is skill sheet 29, 30, and 31.